Okay, so for the second part of 10.2, now we're going to talk about the mean. Okay, the mean is nothing more than an average, right? So we add up all the data points and divide it by the number of data points, and that is our mean. And that is on page 708. There's a blue box in the middle there, and it shows you how to calculate the mean. Okay? And then there's example 7 on how to calculate it. And again, it's just adding them up and dividing by the number of samples, okay? We can also use what is called a weighted mean. So in other words, if you look at example 8, now there's a difference in example 8 and then example 7. So example 8, if you look at the table 10.19, there are 2 10s, 2 9s, and 3 8s, and then so on and so forth. So instead of writing them all out, you're just going to go ahead and say, well, this is how many times I got that. So when you're adding the number of, when you're trying to add the number of all the data points, you have 2 10s, so it's going to be 10 times 2. You have 2 9s, 9 times 2. And then you have 3 8s, so you're going to go 8 times 3. You add them all together, and then you're going to add the frequency numbers up. If you add them up, there are 30 of them. And you're going to divide it by that just to get the average. Okay? A weighted mean is when you have a certain weight to different numbers. So different numbers mean different things. So let's go to example number 9. If you go to example number 9, it says, at Marty's school, it is an administrative policy that the final exam must count for 25% of the semester grade. If Marty has an 88.5 average going into the final exam, what is the minimum exam score he needs for a 90? So this is a question I get asked all the time, right? Oh, Mr. Ron, what can I do? Well, how bad can I do and still maintain a whatever it may be, right? So you guys like to ask this all the time. Example number 9. So I have 88.5 for basically what amounts to 75% of your grade, right? So this is 75% of your grade, right? And then on the final, if I got X, if I scored a point X, right, and that's going to be 25% of my grade, right? And I want these to add to at least 90, correct? So that's what we're trying to solve for, right? Okay? So what do I get? I get, if I calculate this out, What do I get? Oh, so the book actually does 89.5 because they figure that anything greater than 89.5 you round up to be 90, right? Okay, right? So if I multiply this, so I do the math out, what do I get? I get 0.25 x is equal to 89.5 minus 88.5 times 0.75. You divide both sides by 0.25 now, right? 0.25. If I do that, I get 92.5. 92.5. So it seems as though Marty needs to score a 92.5 on the final or better to get the A. Okay? Now, next we're going to talk about variance and standard deviation. Variance and standard deviation is the measure of how spread out the data is, okay? So if I'm going to have data that looks like this versus data that looks like this, okay? Which one has the greater variance, right? The black one has the greater variance, right? In other words, it's more spread out, which means that the standard deviation would be larger, okay? All right? Or the variance would be larger also, okay? The difference between the variance, right? So if I have the variance, and I have the standard deviation here, the relationship looks like this, okay? And just realize that this is there, okay? I'm never going to ask you to calculate a standard deviation or variance, because if you did the one-bar Stetson from the last lecture, you will see that the standard deviation is included in the one-bar stats, okay? So it's nothing more than you go ahead and populating the L1 and then doing the one-bar stats test to find out what the variance is, okay? So that's that. Normal distributions. Normal distributions is what we call the famous bell curve, right? It's the bell curve, right? Normal distribution. Normal distribution is, in statistics parlance, it is the golden rule. You want to try to make sure that everything is or closely approximates a normal distribution, okay? Normal distribution bell curve looks like this. Okay, this is symmetric. This is exactly symmetric across the mean, or the mean and the median are the same, okay? So the mean and the median are the same, and it's going to be symmetric across each other, okay? Next thing we're going to learn here is that the 68, 95, 99.7 rule, okay? What that means is that one standard deviation away from the mean, one standard deviation away, okay, if I was to find one standard deviation away, 68% of all the data will be between these two lines, okay? All right, 68%. So this is 1 sigma, okay, this is not writing, so this is 1 sigma. This is the blue one, right? 1 sigma. This is 2 sigma. 2 sigmas away. You can go another standard deviation away from here, over here, and from here. So from here to here is 2 standard deviations. Here to here is 2 standard deviations. And from here to here, that entire range is going to be 95% of the data. Okay? And the third one is going to be, if I go out another standard deviation away, from here to here, so I have 1, 2, 3 standard deviations lower than the mean, and 1, 2, 3 standard deviations higher than the mean, or the median, right? From here to here, I'm going to have 99.7 sigmas, okay? So that's what that means. Okay, that is the rule, 68, 95, 99.7. So why is this important? So let's say that I gave you guys a quiz. Okay, I gave you a quiz and the average score was 80. The average score was 80 with a standard deviation of 10. Okay? So if I ask you how many people scored between 60 and, not 60, let's say I did 70 to 90, what would that be? 70 would be right here because it's 1 standard deviation away, right? And 90 would be here because it's another standard deviation. Standard deviation was 10. So 70 and 90 would be here. And between these two, you're going to get what? 68%, right? So this would be 68%, right? If I asked you how many scored between 80 and 90, what would your answer be? 80 and 90 would be from here to here. Okay, so that's half of the 68% here, right? So it's going to be what? It's going to be 34%, right? Again, I could ask you how many people scored 70 or less. 70 or less would be what? From here all the way out here, right? So from here to here, right? So from here, so how would I find that out? How would I find that out? From here to here is what? That's 50%, right? Because half of them are going to be less than 80. But I also know that from here to here was what? This is 34%, right? So 70 or less is going to be 50 minus 34, 16%. Okay? Get a little tricky here, right? If I ask you how many people scored between, I don't know, let's say 60 and 90, how would I do that? 60 and 90. So 60 and 90 is what? From here, 60 to 90, right? But from here to here is what? That is half of the 95%, right? Half of the 90%, 95%, so it's going to be 95% divided by 2. But then from here to here, what percent do I have? I have the 34% here, right? 34, right? So it's going to be 47 and a half, so that's like it's 81.5%. Okay, and this is why you want it to be in a normal distribution, because it's easy to gauge this, okay? And if you're asking, well, what if it's 1.5 standard deviation or half standard deviation? We'll talk about that when we actually get to the statistics class, okay? So that's the normal distribution and some of the questions that I could ask you on that. Page 712, there's a blue box there that states, again, the 68, 95, and 99.7 rule. All right, so let's see if we can do example 11 here. Example 11, it says, based on the research data presented in example 10, would a loon chick weighing 95 grams be in the top 2.5% of the newly hatched loon chicks? Okay, so what is example 10? We did not do example 10. In example 10, we had a X bar, or the X bar was, what was it? X bar was 87.49. And the standard deviation was 3.51. Okay, so the question was what? And the question was, would a loon chick weighing 95 grams be on the top 2.5% or not? 95. So 95 is how we have to find out how many standard deviations that's away, right? How many standard deviations is that away? If I had 2 standard deviations away from here, what would I get? That would be 87.49 plus 2 standard deviations, right? So it would be 87.49 plus 7.02. Add these together, it would be 94.51, right? 94.51. So 94.5, and so the question was 95, right? So in other words, 94.51 from here up is what percent? Right? From here to here is 95, right? Here to here was 95. So here would be 2.5, right? So this point, the 2.5 point for this one was what? 87.49, and I calculated it to be 94.51. And the question was 95, so it's going to be over here. So yes, indeed, it would be in the top 2.5%, correct? Okay, so that's example 11. And we are done with 10.2. 10.3, I mean.